Now, I would like you to join us for a discussion about operational ML and how companies can drive business value from it.
Thank you, Mike. I'm really excited about our next session here, which is going to be a panel discussion about the transformational qualities of machine learning. And so to build on the Redis Day theme today around machine learning and artificial intelligence and how that relates to the broader theme of application development, I am joined here by two very knowledgeable and experienced gentlemen. Mike Gualtieri from Forrester Research. He's a vice president and principal analyst focused on artificial intelligence and quantum computing. And I'm also joined by Mike Del Balso, who is the founder and CEO of Tekton, an emerging machine learning company. To baseline the conversation, I actually wanted to really kind of talk about just building software in general. And, as companies really think about bringing this, AI and ML capability within their organizations and sort of mainstreaming the technology, it is a process where you really have to build software, build systems, and building software as it is a hard task. And then when you have to look at scalable, maintainable, and reliable software, that's even harder. And as organizations of all sizes think about, not only looking at sort of legacy software and processes and operations, but figuring out how do they sort of modernize the data architecture to meet these emerging needs, whether they're specific to AI, machine learning, or digital transformation overall broadly. Using that as a baseline, I'd really like to first sort of direct the question to Mike G, which is, what are some of the market trends and insights you're seeing sort of related to AI and machine learning infrastructure more broadly? And any of those things that you might find beneficial for this audience?
Yeah, so there's been an evolution that's been taking place over the last 18 months, 2 years. And to simplify it, all of the tools and technologies have been focused on data scientists and data science teams. And what do those teams do? They build models. Right? And those models, those machine learning models, are the nuggets of intelligence that then go into applications. Now, the evolution that we've seen here, and this is based on the fact, and it's fact because we've polled many enterprises on this, that AI has become foundational. It's become strategic for enterprises. It's not a science fair experiment. It's not an innovation experiment. Most companies believe that they're going to need AI. And when that happens, all of a sudden, many more roles get involved. And I'm really glad that you brought up the notion of software, because AI is software, and those software development processes are very important to getting that model, to operationalizing it, to get the business value in those applications. So this evolution is sort of from the ML tools to an AI platform. And that platform has more capabilities across the entire life cycle, and it supports more roles. So, the idea of ML ops, we call it model ops to be broader. The idea that Mike brought up about a feature store that has huge relevancy at both the beginning of that life cycle and also the inferencing side of that life cycle. So this is becoming mainstream. And all of the components and capabilities, from databases during inferencing to data lakes during the training to application development capabilities in the middle of that life cycle, they all are now relevant to AI platforms and AI teams.
No, that's great. And I really like the fact that you've sort of echoed this thing around, it's a combination of so many aspects of software, operations, underlying infrastructure that feed into that ML platform. And I think as many companies are on this path to bring that capability in-house, you've had some of the big hyperscale companies really kind of pioneer this, and I really like to call them the pioneers of ML platforms, because they've sort of been ahead of the time in building all these different capabilities to power their machine learning needs. And one of them is Uber, right? Started their effort much earlier on, but then I believe circa 2017 they started to share more of their learnings and their reference architectures. And better known as Michelangelo, which is the Uber machine learning platform that supports training and serving of thousands of different models in production. I think a lot of great things came out of that, and luckily, Mike Del Balso, you were one of the leaders in there in defining the requirements and the development of Michelangelo, and that sort of formed the thesis of your current company here, Tekton. Can you tell us a little bit about that journey in building Michelangelo and sort of the implications and the trade-offs between building capabilities, buying versus capabilities, and actually reinventing stuff that didn't exist before?
Yeah, for sure. I think even just kind of playing off what Mike just said, there's been this kind of evolution of kind of like from a focus of, hey, we got to make it possible to build models, to we got to make it possible to build ML applications. And that's the ML applications are really the thing that's in production that requires, that's when you have not just a data scientist building models, but you have an engineer or product engineer involved, probably an ML engineer, and that's a kind of a different focus from a tooling perspective, where you can have a tool that's focused to make a data scientist's life easier when they're doing data exploration and model building, but it's a different set of tooling and it's a different problem to support, like a whole team that's building and managing an ML application that's driving the business's revenue in some way, some critical use case, like the customer experiences. And so I'm drawing that distinction because I think that distinction of data science focused versus like ML application focus may actually be like a separate distinction from having a focus on a single application versus building ML infrastructure, or like a platform. Because you could have a platform that's just focused on helping data scientists build models, but I think what we've seen over the past few years is a shift from the tooling to just help the data scientists build models to really high quality tooling that enables a whole team to build and maintain machine learning application in production. And that's not always just a data scientist. That's often a team of a data scientist, ML engineer, and often a production engineer who's responsible for the end product, the front end, the application. And for them, also, often machine learning is just an implementation detail. They're just trying to build their product. And so we kind of like went through that journey at Uber. So when we started at Uber, we went through both of those shifts, both of those kind of changes. When we started at Uber in 2015, we had almost no machine learning in production, and data scientists were blocked. They didn't have a common set of tools. They didn't even know where to access data. They had certainly no path to production, but they had no eng support typically. And so someone would either be in the state where they've built something kind of cool, like a cool prototype, but they didn't know how to put it into production, or maybe if it's something really important like surge pricing, the whole eng team would be staffed up to deploy it to production. But what was most common was just data scientists that got a lot of other things to do. And so, they would work on building some dashboard, doing some business analytics, some business intelligence kind of stuff, other things where data scientists could add value. So our goal with the ML platform at Uber was really, and we called it Michelangelo, was really to democratize machine learning, make machine learning possible for the more than 100 use cases that we identified from the beginning, where machine intelligence could really influence the product and customer experience. And we did that by really doing both of those things, by providing the tools for the data scientists to build their models easily and access their models easily, but also by focusing on the kind of end-to-end story of a machine learning driven product. And what that meant was we spent time with the product teams, the people who were actually on the hook to deliver business value with this stuff, because when you have that model built, that's not even half of the story. There's like many more projects to do to build feature pipelines, to productionize a model, to monitor it, to productionize feature, all the data infrastructure, and integrate it with the end business application, experiment with it. On all of these things were problems that we saw. We helped one team do, we helped the fraud team do this, and then we go to the safety team or the pricing team, and we're seeing them deal with the same problems. And so we took an approach. This is kind of like in the early days of ML platform, but we were just working with different teams again and again, and we were noticing the repeated problems across these use cases, and then we were building those into automating that really and building those into the platform. So it's a very kind of like use case driven approach to determining what belongs in the central platform or not. But it was quite successful, and we had after like 2.5 years, we had something like tens of thousands of models like running live in production, doing real-time inference, working off real-time and slower data, all kinds of stuff across a variety of use cases. And I think it really was like one of the great kind of examples of a success in the machine learning platform journey. I know of a lot of teams that try to do get going with ML infrastructure and an ML platform, and it's really easy to go down the wrong path and make a lot of mistakes and be 18 months later and not have a lot of output there. So I think we were really fortunate in how we approached it, by both focusing on the data scientist, but the other personas, and both focusing on the model and the data part of the use case. And I think that's what led to our kind of like unique success at the time with the ML platform at Uber. Michelangelo.
Yeah, no, that's pretty amazing. And, the fact that you've highlighted this distinction of, there's sort of a set of tools and processes that empower the data scientist. And then when you actually look at what needs to be done then to, push that into production, you have this whole different persona of, ML infrastructure that needs to be addressed, right? And so as we think about these best practices and these sort of learnings from the architectural work that you did at Uber, and many folks have done at other companies as well too, you see this natural formation of new categories, right, within ML infrastructure. So feature stores being kind of a new category that's been created, or certain categories that existed, but then they're being more well defined. For example, like model observability to detect model drift and data drift and those kinds of things. This next question is more for Mike G, which is, as you look at the space from AI infrastructure and these different categories that are being formed within this broader umbrella, what are your impressions of these new categories, and how can decision makers that are thinking about building versus buying make sense of these categories, which are still very nascent and being defined as we build it, right? So what are your thoughts there?
Yeah, so enterprise architects, solution architects at a company really need to get involved and understand this entire process, that Mike was just talking about. Because a lot of the data scientists at these teams, their software experience is in maybe writing R or Python for the purposes of analyzing data to build a model. And if you're at a company like, I'm just picking Bank of America, or a large chemical company, or a large supply chain company, or any large company that has a huge portfolio of applications and data, that is a very complicated environment, right? That is in some ways immovable, right? So all of these new categories are coming around to sit on top of that existing architecture to make that work. So one example of that is on the inferencing side. Because a lot of machine learning has been the science fair, data scientists their goal again is to output that model. They don't understand latency. They don't understand that they train the model on 20 columns, and the algorithm picked out 6 features that have the signal in it, but only 4 of them actually come in on the payload. Where are they going to get the other 2? Well, the other 2 are buried in DB2 somewhere. Forget it. You're not going to get the latency. So you're going to need some sort of a cache or a database to serve up those models on the inferencing side. These are architectural problems that are completely familiar to solution architects and enterprise architects. They've solved them before. And so they more than, I would say, more than data scientists, understand some of those tools and will understand those categories. And that's what I was saying in the beginning. This is the evolution going from data science to the larger AI team that consists of these multiple roles. It's just those roles, like architects and software development, have to step up, and the leaders have to let them step up and be involved in that process.
Yeah, that's a really good insight, and I'm glad you actually mentioned the whole thing of roles. Mike D had also mentioned personas, and one of the things that I see is that as you try and go from model building and the work of the data scientist, and then really think about productionalizing it, we've almost asked a single individual to basically overfunction, right, in being able to take the model, deploy it, and all that. But what we're actually seeing is as these categories are getting formed, you have natural personas that can, be really tailored to do a specific job, right? And, Mike D, I've heard you talk about this whole concept of operational ML and, how that ties into the broader ML ops lifecycle. But more importantly, this emergence of this role of the ML engineer. Can you talk a little bit about, the operational ML category, and then what does the ML engineer entail?
Yeah, for sure. I think so operational ML, what we mean by that is especially at Tekton, we focus on helping organizations put machine learning into production. So when you're using machine learning to power your product, to power a customer experience, an important business process, there's some level of productionization that is needed, and we think of that as operational. So that's operational ML. The kind of like traits that characterize this, typically it's a real business value situation. It's not kind of like an experimental side project type of thing. Typically it's got pretty tough product requirements, right? It's something where it needs to have a certain uptime, otherwise the company's going to lose money. Think of like a fraud detection system or something like that. So maybe it needs like some real-time capabilities because it has to be integrating data and like new knowledge in the business into these decisions as quickly as possible. Maybe it needs to serve at scale because you have a lot of maybe you are Bank of America and there's a lot of people logging in at every second, and you got to determine, is this a fraudulent user or not? And that could be thousands, tens of thousands, hundreds of thousands of requests per second. So there's this kind of like mixture of, hey, this is an important use case, but also this is like a real engineering project to support this as a reliable application. And so that's typically what we mean by operational ML. What's fascinating about it, and to get to the machine learning engineer thing, is there still is the person who's the product engineer, who's the consumer of the machine learning signal, the person who's calling is this fraud function that ultimately is going to make a prediction and stuff like that. And then they determine, okay, then if this is fraud, let's not let the person log in, or which movie should I recommend? And then they'll look up the movie link and recommend that on the website. Or what price should I recommend? And then they'll put the right price to show to the user. And ultimately, these are just kind of like the product engineer is just trying to get the right decision, and the stuff that's powering that decision is all of the machine learning work, right? It's the model, it's the feature pipelines that are feeding that model to make that decision. But they're all kind of implementation details, and usually these applications can be simplified to the point, to dramatically oversimplify, but as an API to the person who owns the end use case, who's saying like, give me a decision. Should I ban this person? Should I recommend this item? Stuff like that. And if you think about that as a library, I think of the ML engineer as the person responsible for that library, the person responsible for making sure that function is working for that user. And these functions are always, they tend to be pretty unique to the use case. There's always business specific nuances. There's business specific data sets, but also you might like design the ML, the decision system, in a way that's, for example, unique to Bank of America. It's going to be different than how they make their fraud decision compared to their competitor. And so the machine learning engineer is the person responsible for all of those engineering systems to deliver those predictions accurately, reliably, and in a way that is also meeting the engineering requirements, the technical requirements of that product. So in real time, at scale, whatever it is, integrating real time data into it. And so I see that ML engineer is ultimately responsible for that. The data scientist is someone within that project that is really like deciding on the core algorithmic elements, the data science of it. But when we work with customers who are operating machine learning at scale for real revenue driving or cost savings use cases, there's always an ML engineer. There's always an engineer behind the scenes who's ultimately responsible for this system working. And in my mind, that's what I think of as the ML engineer.
Yeah, no, that's really helpful. And I mean, I think it really echoes and further strengthens the point of, there are so many different aspects to the platform itself, requiring different sort of skill sets along the way, because you're powering a broad set of applications, right? Whether it's fraud detection, recommendation systems, and just the nature of that, going back to data sources and the different data sources that you have to actually connect to actually go do a prediction on fraud detection or a recommendation. You're getting data from multiple kinds of sources, whether it's relational databases, data warehouses, NoSQL systems, or even data streams, right? And so there's this notion of like there's no one database that's going to solve all the needs, right? And so you have very purpose-built kind of data stores that need to be part of this broader platform. This next question is really for Mike G, which is, as you think about the categorization within ML infrastructure, this whole notion of purpose-built data stores, and how does that play into the overall decision-making process for what to select underneath, right? Because you have data lakes, you have data warehouses, you have NoSQL systems, right? So any thoughts or impressions there?
Well, I mean, if you think about what Mike was talking about and what you asked about, which is the ML engineer, and you think about, well, where does an ML engineer come from, actually, right? Are they more the ML or are they more the engineer? And Tamir, the question you're asking is more the engineer question, right? So I would think it would be easier for a solution architect, an engineer who understands complex systems, including databases and things like Kafka and everything, right? To learn what they need to know about ML to architect that solution versus an ML expert, for example, a data scientist, to do that. I think the good news about that is that most companies have that role, and they just have to step up and learn the ML side of it. And those are the people who I think also need to be involved in that decision over purpose-built data stores and the type of data store that's needed. And I'll come back to most enterprises. Most enterprises started many, many years ago. And because of that, they have an enormously complex environment and one of every database, through acquisitions or just, as the eras go on, right? And there was a good decision why they got each one of those. But if you're dealing with intelligence AI is real time. And so many of the AI applications have to happen in real time. In fact, Mike, every example he gave was like milliseconds, fraud detection, braking in an autonomous vehicle.
And the most important use cases we work on, if there's economic value there, it's
right.
It's only going to be more accurate if you can integrate that information in more real time. So
yeah,
totally
but the reality is, get to the data store question, is the reality is that a lot of the data that's needed to make that decision, like I said before, does not come on the payload. So you need to enrich the payload with the data that the model needs. And that is a key reason why people should consider architecturally a data store that can combine that data, have low latency. Now, if it's a net new application and it's transactional, same thing, like that low latency. Like a lot of people, they'll say, "Oh, yes, I'll just do a RESTful call to the model." Don't have time. Do you think when you swipe a card or you tap a credit card that they have time to make a network call to a service that then returns the result? No, it has to be done during the transaction.
Yeah, absolutely. No, it's a spot on point, and going back to what Mike D was saying, that like latency, has economic value to it, right? So then the lower latency, you can maximize your ability to, detect fraud much faster, and then hence saving the money on that. Well, Mike G and Mike D, thank you so much for the time and the insights that you shared with us. I found it very beneficial, and I hope our audience also found it really beneficial. So I want to thank you both for participating in today's discussion.
No, thank you. Thank you for having us.
Thanks.
Yep, absolutely. Thank you, everyone, for viewing the panel. As we go over to the next session, I'd like it to turn it over to Mike Anand. So, Mike, it's all yours. Thank you.
That was an insightful conversation about AI and ML and how companies of all sizes need to make important trade-offs that enable innovation.